This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, after preparing some test leads, then testing the output current of the breadboarded power supply, we will modify the circuit to enhance output voltage range. Before I could test the output current of the breadboarded power supply, I needed some test leads, alligator clips on one end and pin compatible with the breadboard socket on the other. And I happened to have 10 test leads, alligator to alligator, that I have not used for many moons. So I cut them in half and then soldered some pin compatible with a breadboard socket to the opposite end of the alligator clip. Now, this could be an old component lead. I happen to use a stranded wire terminator on two of these, which ends in a pin compatible with a breadboard socket. And on two of them, I used a test point feed-through that could also be plugged into a breadboard socket. I have a pin and an alligator clip, and I put some liquid flux on and solder the two together. And moving right along, repeat this 4 times. The feed-through pins I have to work with horizontally. The green stranded wire terminators need to be soldered vertically. Apply some flux to both sides. I have to make sure that the stranded wire has been sufficiently tinned because I want the solder to melt into the termination pin. Insert the wire into the termination pin and apply some solder to an already tinned wire. Once the wire and pin have been soldered together, I like to apply some epoxy glue to the joint because solder can creep up copper wire and that joint can be brittle. So I'm applying some epoxy glue to the joint. This is the 5-minute epoxy glue that sets in a couple of hours, or closer to 24 hours. It's relatively clear epoxy until it sets. In addition to this epoxy glue, I'm putting heat shrink tubing around it as a final means of structural support and also insulation. It might be embarrassing if you accidentally touched one of these leads, if it's carrying higher voltage and current than you particularly care for. I'm just twisting the heat shrinkable tubing on. I use the smallest size that will fit around the epoxy glue and onto the insulated wire. And sometimes it's a stretch, so to speak. And it gives me 4 new connectors. Now that I've got the heat shrink tubing on and in place, I need to apply some heat to shrink the tubing. This is a hot air gun, otherwise known as a surface mount rework station. I've used it a lot more to shrink heat shrinkable tubing than I had to rework surface mount stuff. Stuff is time consuming, but it only has to be done once every decade. These things don't wear out once you've got it. Normally the weak point is exactly what I'm working on now, the joint between the pin and the wire. But I think I've done a good enough job here. I should point out the leads of this thing have to be short as is workable. All right, now that I have 4 of these things newly minted, I can move along to testing the output current of the breadboarded power supply. Now that I have the test leads, I want to do some output current testing before proceeding. I mean, if this thing can't provide 0.5 amps as specified, it's pointless to go forward. I've got 2 multimeters. The top one is measuring output volts, and the bottom one is going to be measuring current through a load resistor. Let's just make sure we start off measuring the same stuff. I've got 14.03 volts coming in. Now I've got roughly 2/3 of the 100 ohm 10 watt resistor. That's about 66 ohms, and I should get 0.2 amps, and I do get 0.2 amps. Now I'm going to switch the leads, and I should have 33 ohms, and I get 0.52, 53. The temperature of this transistor seems to be going up, and at 15 ohms I'm going to plug in this load. I get 0.90 amps, but I notice that the output voltage decreased to 13.84 volts. I'm not sure what that's about quite yet, but I suspect it's got something to do with the temperature of this transistor, which is really quite hot. I took my original notes with scribbled formula and I converted that to a spreadsheet and set up the spreadsheet for the actual input voltage measured, and the output voltage I've changed to 25 volts and output current at 1 amp. And there are some changes I'm going to need to make to R2 and R5 parts of the voltage dividers going to the inverting and non-inverting inputs. There's also a change that I need to make to R7, the input resistor to Q2, and R9, which is a resistor connected to the output zener. I'm going to make changes to R7 and R9 first. My minimum voltage this time is 106.3. Just want to check the input voltage. It's a little low, I think. Yeah, it is. It's like 27.84. I'm not sure exactly what that's about. It could be my previous current tests that heated up the transformers. Okay, so my output is 21.5, and now I'm going to, having shut off the power, change R7. This is the input to Q2, the 2906 transistor. I've already changed R9. Got to actually connect these things before I can test them. Yes, there you go. Okay. Press down on that and make sure the other end is properly seated in the breadboard socket. So much for R7. And my new output voltage has not changed. It's 106 millivolts, 21.56 maximum. The change to R7 really didn't affect anything that I can see in terms of voltage. Now I'm going to extract R5 as part of the inverting input to the 723. Swap out that resistor to a value consistent with the spreadsheet. Working in a little crowded conditions here. Yeah, you can get it in there. Come on. That's R5, and now we need to do R2, part of the non-inverting input to the 723 differential amplifier. Those two resistors are the same. Oh, okay, finally. Now, power on, and this is set to maximum. I'm getting 26.54 volts, which doesn't quite make sense to me, but I'm looking at it. Now let's take to minimal, and it's taking a while to quiesce, but it's below 100 millivolts. And I want to see if this is going to go below 90. I don't know why. I don't need anything quite this low, but... Okay, 91.0. In this video, I fabricated some alligator-clip to breadboard-pin test leads. I did some preliminary output current tests at 0.2 amps, 0.5 amps, and 0.9 amps. I modified the circuit as published to bring it more in line with the formula in my notes, extending the output range to higher than 25 volts and going down to 91 millivolts. In the next video, we will start work on the printed circuit board for this positive power supply. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.